and welcome to Playing with Gravity. I've been playing during the lockdown with a chip. I've been sat around in my chip box for so long. All the documentation for it claims it's being obsolete, but it still works. It is in fact an ADXL 202 accelerometer dual axis. What I'm doing is I'm using it as just basically a gravity sensor. So currently the software is not fully trimmed and so the board's at a slight angle, but I've got it so that the LED is in the center of the display, and as you can see, if I tilt it, the bubble runs up the hill. Exactly like it would do if it was a bubble in a glass level. So that's what it looks like. That's how it works. It's a PIC microchip running the software, and so if we have a look at the data sheet, you can see smack across it, obsolete, which gets in the way. You can see basically there's a Y sensor and an X sensor, and they are micro machined parts, obviously machined into the silicon, and I think they act like capacitors and they change as they move. They change their capacitance. You get two channels out and you filter them through the filter, one filter for each side, and then it goes into a duty cycle modulator, and as you can see you get square wave out, and it's sort of PWM, the width of the high time or the low time changes as the angles change, and that's what I'm detecting. I'm waiting for the input to go high, and then I time how long it's high and produce a number, all the usual guff on how it works. And as you can see here, the chip is in the vertical orientation where I've got it horizontal, but it still seems to do what I want. It may not be as accurate as how it should be used, but it does work. And there's the rest of the data sheet telling you all about it and the theory of operation. But the data sheets are on the net, so you can always get it down. And here's another sort of look at it without the obsolete written straight across it. And you can see it's just a sensor, a demodulation circuit, an RC filter, and then this duty cycle modulator. And then it comes out and into my PIC. Here you see it with the scope, and you see I'm tilting the board up to 90 degrees, and you can see the pulse width on the top trace changing, and there I am 90 degrees the other way, and then back to the middle again, and it should be about 50%, and then rotating that way, and you see the bottom blue trace is changing more, and then 90 degrees the other way, and it's showing you the range of the outputs from the board. You can see it's a little bit wobbly desk, and it's not gone right back into the center, but it's good enough. And now back to the description. Look at the PIC program. There's just a little bit that says, you know, what ports are doing what, and what are the rows and the columns. This section is, if you're used to Arduino, Arduinos, is what they call the fuses, or as Microchip refers to them as the configuration bits. This is just setting up the chip. We've got the internal oscillator. The watchdog is disabled. The power up enable bit, timer is disabled. The reset pin is set for a reset. There is no code protection. There is no data protection. Brownout is on, so we'll get a brownout interrupt if the voltage drops. We have the internal external switchover bit, and we have the failsafe clock monitor, and we've turned off the low voltage programming, which doesn't matter because I program it from a PICkit 3, which is the Microchip programmer. It's all happy with that. And the brownout detector is set for 4 volts, so if it drops below 4 volts we'll go into brownout and it will signal that condition. And the write protect is off. We head into all the defines, so you know, true, false, enable, disable, All the numbers that I use later on, I've just given them names. If the same number gets used in loads of different places, I can change it here once, and when I compile, it changes in all the other places. What the output bits are for the various columns, the limits as to when the LED should change on the output, and again for the rows and a row limit. We have function prototypes because it's in C, and so these are here to let the compiler know to expect to see them later. And then we're into the variables, all the different variables I'm going to use. And then we're into, I suppose, what Arduino would call the setup. So I call this routine from the main routine, and it basically just initializes the I/O, sets all the ports to be inputs or outputs, sets the capture and compare registers to 0, then it clears the port down. This is the interrupt routine that gets called on the rising edges, and so basically what happens is it comes in, works out which capture and compare 1 tripped, so whether it was capture and compare 1 or capture and compare 2 is flagged up as an interrupt. It basically starts the timer and sets a capture for falling edge. So that what happens is the next time round, when this one interrupts again, it will come back in. It will take the amount of time taken between detecting the rising edge to detecting the falling edge, and then it just highlights the fact that it's got new X data, sets the interrupt flag to false, ready for the next one. And it's the same here. This is for the capture and compare 2, exactly the same. They just get called alternately, and I just measure the high period of that pulse width signal. I see, get down into main, we set up the I/O as you've seen above. We enable the interrupts, but then we enable the global interrupt so that all the interrupts are running, and then we go into the while one loop, which basically loops forever. We start the conversion to basically, we fall in here the first time, we set the flags in, set enable flag, interrupt enable flag, come into here, we set the interrupt enable to true, and we clear the flag. We then set the capture and compare register so that the mode is rising edge, and we then say that convert X is false. And what will happen is that will set the conditions to capture the rising edge for the X signal. The interrupt will then get called, set the timer going, and then the next time an interrupt gets called, it's the falling edge, and we then have the time that pulse was high. And so basically it's either going to convert X or it's going to convert the Y. So if convert X is true, we do the X axis, and if it's false, we do the Y axis. So we're just going X, Y, X, Y, X, Y as it goes around the loop. And then here we have a little routine. There's 2 of these, one for X, one for Y, and it basically, if there's new X data, it just comes down, adds it into the average. It's like a rolling average. When we get to a certain number of counts, we decide that we've averaged enough, and we go into the display routine. And that's very simple. It just sets the column depending on the average value of the X, and it just says, you know, is it less than this? Yes. Or in column 1 then. If it's greater than that, go on to the next one. Is it greater than that? Yes, go on to the next one, until it finds one that it's less than. And of course, the number must be greater than all of these by the time it's got to here, because if it was less than any of these, they would have matched the condition, and then it would have fallen out the statement. And it goes right down to the end, and if it hasn't reached anything, then it just sets the last column to be the active column and starts again. And it's the same as the Y one. It comes in and it just sets the Y up. And so at the end of this, you should have a 1 X output that is high and 1 Y output that is low. And so that will light up the appropriate LED. And so as you move it around, of course, the X column changes and the Y row column change. So the LED moves around. And that's it. That's all it does. Like the Arduino, you got the what they call fuses here, the configuration bits, and basically you can go into IDE and you can set all of these bits to how you want them. You click on the generate source code and it basically gives you some code which you simply paste in here. So this was generated by the configuration bit program, so you don't have to remember what all these are and know what they are. You go into the configuration bits and it tells you all the bits that you've got for your particular micro, because you've told it what the micro is, and you just set them up, and then it will generate this text. It tells you what they are, what they're doing, so it puts the help bits in for you, so that makes life quite easy. I do recommend that people should get hold of some PICs. You can get programs off eBay quite cheaply, and all the software is free. Just download it from Microchip. You know, they're not as snazzy as Arduinos because you don't get as much RAM, you don't get as much flash, but they are, in my opinion, super little chips and can be very fast. If you like what you're seeing and want to see more of it, hit the subscribe button, click on the notification bell, and I'll see you on the next one. Oh look, a bit of noise. Right on the boundary. There we go. Job done.